Today we will talk about window functions. Let's assume that this here is one scenery, and inside of this scenery we have people looking through binoculars. And each of them has a different location, so each of them has a different perspective, and none of them will be able to see the whole scenery. They will be only able to see a part of a scenery. So this is the same as each of them had his own window, and if he would be able only to see what is behind that window. Now, for us, our scenery will be one database table. And I will assume that in each row of this table, we have a data scientist. And for this data scientist, in this fifth row, this row will be his point of view. So this is a current row for this data scientist. And this means that from this row, he can only see one part of a table. For example, he can see rows 3 and 4, but he cannot see the whole table. So we can see that because of that, he also has a window. So what would data scientist do with a window? Well, he would usually calculate some kind of aggregation on values from that window. So for example, he can calculate an average value for 3 and 4, and that would be 3.5. We can better see that on this image here. For example, data scientist from this last row calculated an average value of 3.5 for his window. But the other data scientists can do the same. For example, this one here calculated an average value 2.5 for these two values. And we also have this data scientist here who calculated the average value 3. As a result, we got one whole column. So this is how window functions work. They will give us a column as a result. So first we define some window, and then we calculate some aggregation on that window, and at the end we will get a new column. But here we have one problem. Our windows are too random, and this is problematic. This is not really a scientific approach. What we need is some rule that would connect all of these windows, and that rule would help us to define windows with only that one rule. And for that, I will give you one example of such rule. For example, we can calculate moving averages. So what is a moving average? In this special case, we will say that this is a current month. And we will also take two previous months, and that is how we will define our window. And for this window, we would calculate an average value. We can do the same with April as a current month. So April, March, and February would be together a window. So this would be again an average value. And we can do the same for March, February, and January. We again can get an average value. We can see that better on this animation here. If this is our current window, this would be our average value. If this is current window, this would be an average value. And for this window, we would get this average value. And this is how we are calculating moving averages. Now, if we want to define such rule in SQL, we would use window functions. So window functions will at the end aggregate values, and they will do that with some other functions like sum, average, max, or there are also some special functions that only work with windows. Window functions are also called analytic functions because they are really useful for data analysis and for statistics, and there are some things that are really hard to achieve with other SQL statements but can be easily calculated with analytic functions. And now I must tell you that previously I said that this is a window, but that is a wrong terminology. So this is not really a window, and this here moving average window is also not a window. So we have to clarify this terminology. And for that, I will go here below. Here we have three small tables. They're presenting some sport results. Inside of them, we have these red moving rectangles. And these rectangles are not windows. They are frames. So their correct name is a frame. So what is a window? Well, in the real database, we won't have three small tables, but we will connect them into one big table. And here we have that big table, and this big table has all of the rows that we will work on with our window function. And this is our window. So all of the rows that window function is working on is a window, and each of these small tables can be a partition. So what is a partition? Partition is a part of a window on which we apply some rule to define frames. So frames are defined inside of this partition by following a rule. So they are defined separately for each partition. Now, how can we define a window? Well, we can define a window naturally. Everything that we place inside of the from clause, where clause, group by clause, and having clause will define our window. All of these clauses will influence what rows can be used for our window function, so they will define our window. And this is the opposite, for example, from subqueries. Here we have one subquery, and this subquery will calculate an average salary for all of the employees, not just the employees from this department, but for all of the employees. So this subquery doesn't have an outer context, an outer filter, but window function does. Window function will respect all of our clauses, it will respect all of our filters, and that is how we define a window. Next, we will see how to define partitions. Partitions are defined by the values from the columns. For example, here we can see that each row which has the same value will belong to the same partition. So all of the rows with the letter A will belong to partition 1, and all of the rows with the value B will belong to partition 2. Earlier, we saw such an example. We saw that each partition here was defined by the value from the column group. Now, we don't have to use only one column. We can use two or more columns. Here we have two columns. So if combination of values from these two columns is, for example, AP, then those rows will belong to partition 1. And if combination is different, for example, BQ, then those rows will belong to partition 4. We also know that it is possible to create new column by using some expression, and this is really useful because it can help us to define custom partitions. We will now see how to define frames. For frame definition, we have to know its starting row and its ending row. We also know that frames are movable. That means that their position is relative to the current row, and we can also notice that frames are always inside of their partitions. That means that we have two more reference points, and those are start of partition and end of partition. We will now go here below to see all of those reference points. In this image here, we can see that we have start row. So start row is the start of partition in this case. End row will be end of partition in this case. And of course, we can use current row. We can also use rows that are relative to the current row. For example, this row here is 3 rows before current row, and this row here is 3 rows after current row. In SQL, we are using specific terminology, and for the start of partition, we say that it is unbounded preceding, and for the end of partition, we say it is unbounded following. Current row will be, of course, current row, and row that is before current row is end preceding, so we would say 3 preceding for the row that is 3 rows before. Similar to that, we can say end following for the row that is after current rows. For example, if the row is 3 rows after, then we would say 3 following. Here on the right side, we have an example of this terminology. So we have a frame that is defined as rows between, unbounded preceding, and one following. That means that our frame will always start at the start of partition, and it will end on the row that is 1 row after current row. Now, all of these reference points can be used to define start of frame or end of frame, but we have some limitations. Unbounded preceding can only be start of a frame, cannot be, of course, end of a frame, which is logical, and similar to that, unbounded following can only be end of a frame, while current row, end preceding, and then following can be both used to define start of a frame and end of a frame. Until now, we were talking about rows. We said that for definition of a frame, we have to know on what rows that frame is. But instead of rows, we can also use groups and ranges. So what are groups? Well, let's go here below, and here we can see one column. And this column has current row. So this is a current row here, and this current row has value 7. But we also have one more row that has value 7. Together, these two rows with the value 7 will define current group. So current group encompasses all of the rows with the same value as the current row. And for defining our frame, we can say that our frame starts with the current group. We don't have to say that it starts with the current row. In this example here, we can see a terminology that we will use for groups. And this terminology is almost the same as for rows. We would say that we are looking for groups that are between unbounded preceding. Unbounded preceding is the same as for rows. It is the start of partition. And on the other side, we are looking for one following. In this case, one following means one group after current group. So if this here is current group, one following group will be this. So one following group will encompass all of the rows with the first value after the value 7. That value is 10. So all of the rows with the value 10 will be one following group. So we can use groups to define edges of our frame. Both groups and rows are all about relative position. For example, here we have first group, second group, third group, fourth group. So everything is about relative position in space and order. It is the same for rows. We had first row, second row, third row, and so on. But there is another way how we can define frames, and that way is based on the values from the column. In that case, we would use ranges. Now let's assume that we have some students who scored this many correct answers on some test. And now we have to grade those students. So for that, we will use this reference table. And inside of this table, we can see that each student who scored between 76 and 100 correct answers will receive a grade A. So this student here will get an A because he has 85 correct answers. And we can use the same principle to define our frame. So our frame will have all of the rows with the value that is between 200 and 300. This is our definition of a frame. Our definition is a range. So these two values here will belong to the frame that is defined by this definition. Now the question is how to create syntax to define that range. Well, the syntax is the same as for the rows and for the groups. We would use this syntax here. Range between 10 preceding and 10 following, where the current row is actually a value from the current row. So 10 preceding means a value from the current row that is 30 minus 10, and that is equal to 20. So our range will start with 20, and 10 following means current value, that is 30, plus 10, and that is equal to 40. So all of the rows with the values between 20 and 40 will belong to this frame, and the values outside of this range will not belong to this frame. For the end, we will look at one example of a real window function. We will start with one simple select statement, and this select statement will take these three columns from the sales table, so that resulting data set will be this. But then we will add one more column to this resulting data set, and that column will be this cumulative column, and this column will be calculated by the window function. And first, I want to tell you that we haven't created any partitions inside of this window function. We don't have to use partitions, so we can assume that this whole table is actually just one partition. And the first step is to define our frames. We are using this definition. Rows between unbounded preceding and current row. That means that our frames are between start of a partition, that is the start of a table in this case, and the current row. And we also said that rows are all about relative position, about position in space. So we have to tell the window function how to order our rows. And for that, we will use this order by clause here. Now we cannot mix this order by clause with this order by clause. This order by clause inside of a window function is only used to define frames. But the final ordering of our data set will be defined by this classic order by clause. So these are totally different clauses, just their homonyms. Now we can show our frames. First frame is this one. So because this is the start of partition and it is the current row, this is our frame. Next frame is this one here. So this is the start of partition and this is the current row. Third frame is this here. This is the start of partition and this is the current row. And we can go until the end. So this will be one more frame. We have start of partition and the current row. We have to decide what calculation are we going to do for each frame. And I have decided to use this quantity column and to aggregate values from that column for the current frame. So I have add this syntax here, and this syntax is also part of a window function. So all of this here is a window function. So we are summing a quantity column for the rows that are inside of the current frame. And that is how we have created these values here. For example, if this is our starting frame, then sum of this value will be 15. If this here is our frame, then sum of these two values will be 25. Next frame will be this, and sum of these values will be 45, and so on. And the rest of this statement is just a classical SQL.